Welcome back to our coding dojo. My name is Andy. Today we're going to be doing the bowling kata. So we've moved on from fizz to something has a little bit more complexity. Um, so let's go ahead and jump into it. So bowling kata. Create a program which, when given a sequence of rolls for one line of American 10-pin bowling, produces the total score for the game. This is a summary of the rules of the game. Each game or line of bowling includes 10 turns or frames for the bowler. In each frame, the bowler gets up to 2 tries to knock down all the pins. If in 2 tries he fails to knock them all down, his score for that frame is the total number of pins knocked down in his 2 tries. If in 2 tries he knocks them all down, this is called a spare, and his score for the frame is 10 plus the number of pins knocked down on his next throw in his next turn. If one of his first tries if on his first try of the frame he knocks down all the pins, this is called a strike. His turn is over, and his score for the frame is 10, plus the simple total of the pins knocked down on the next 2 rolls. If he gets a spare or a strike in the last 10th frame, the bowler gets to throw 1 or 2 more bonus balls, respectively. These bonus throws are taken as part of the same turn. If the bonus throws knock down all pins, the process does not repeat. The bonus throws are only used to calculate the score of the final frame. The game score is the total of all frame scores. Here are some things that the program will not do. We will not check for valid rolls. We will not check for the correct number of rolls and frames. We will not provide scores for intermediate frames. The input scorecard for a finished game where X stands for strike. The input scorecard from a finished bowling game where X stands for strike, hyphen for no pins bowled, and slash means a spare. Otherwise, a figure from 1 to 9 indicate how many pins were knocked down in that throw. So here's some example games: 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we always hit pins, but in your first frame you get 3, in the next frame you get 7, the next frame you get 6, totaling 60. A perfect game would be 12 strikes, giving you a score of 300. Heartbreak would you hit 9, never get a spare, and then a spare every round, giving a total of 150. So those are just some examples. So this kata comes from the Coding Dojo Handbook. So I've done this kata before in a different form. So I've messed around with, I believe it's Martin Fowler has kind of made this one popular. But his form would, you had a class that would accept rolls, and then at the end you'd spit out a score. So this doesn't have those same rules, and so our form will be a little bit different. Also, this is my first time completing this in JavaScript. Typically, I've done this in C# or whatever language I was working with for work. So those are going to be some differences. We'll see how they kind of play out. So we're going to start off by let's make our first game an all gutter balls game. So we'll go and test. We'll call this. Yeah. All gutter balls. So we would expect if we call bowling and we passed in So we want 10, 10 rolls where they're all zeros. Okay. And we expect the score to be 0. Okay. So we expect the score to be 0, but we get back undefined. So that's a good first test. And we can go ahead and make that pass by just returning 0 every time. So that passes all our tests so far. Um, I So I created these files because this was the bowling kata. Bowling name isn't that great a name. Um, we could change it to something like score bowling, something like that. For now, we're just going to keep it bowling, and just because it's simple, we just care about the functionality for right now. So, um, so that's the all gutter balls game. Let's try a game where um, on every roll they just knock down one pin. Okay. Okay. And so this one we want to pass on a string. We want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we pass in 10 ones, and our score should also be 10. So we should. So each roll gives us 1 point. So our first frame we get. Okay, I think I made a mistake here, right? Let's back out here real quick. Okay. Let's see. Trying to find the rules. So we get 10 turns. Each turn, you get 2 tries. So our gutter ball game is wrong. So in order to, so this would be the first frame. This would be the second frame, third frame, fourth frame, fifth frame. So we've only have half the number of rolls. So we had 10 rolls. We actually need 20 rolls. So that should be our actual game. But because we're hard coding 0, the solution is the same. But our test all ones, we want to make sure we actually have 20 rolls because we don't get any of the bonuses, but we have 2 per frame. So let's make sure we have the right number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then, of course, the score will be 20. And, of course, that's wrong. So that looks like a good test. Let's go ahead and see. So we're actually bringing in the. So what do you want to call this? This is our game. It's our input. What are our a line of bowling? So let's go ahead and have our line here. And let's start with our score. And for each, oops, that's not what I wanted. Well, I mean, that is kind of what I wanted. Except we're going to call each of these is going to be a roll. Let's do score plus equals roll. So let's see what we get there. Cannot read. Okay, so this is probably us trying to treat a string like an array. Let's go. Let's start by looking up our for each. Well, let's look at string first real quick. Okay, so we can do indexers on a string. String length. Repeat placer slice starts with substring. Okay, well, let's real quick, we'll go length. We'll go and switch to using a for loop instead of for each. And we need. Okay. So here, it looks like we are actually concatenating character arrays and not actually the value. So let's go ahead and do that. So we go ahead and force the conversion of our character into a number. And add it. So that's great. We could do 2, 3, 4, 5, all of those will work. Um, at 5, though, if you do 5 and 5, um, we wouldn't actually write it um, 5 and 5. We'd write it 5 slash. Let's go back to our rules here. Ah, so we've missed another rule. So our first line, we shouldn't be rolling zeros. We should be having dashes. So we messed that up again. So let's go ahead and fix that. We'll go ahead and change our test here to be 20 dashes. And now our code is going to blow up. Okay, so it's nan. So I think what we want to do is go let's go ahead and create something called maybe the roll value. And let's go ahead and switch on line I. Value equals 0. So that's kind of redundant. Roll value equals okay. So now we convert our dashes into values. I used a switch statement. We could have used an if statement here. I used a switch statement because we know there's at least 2 other things that are going to be coming. We're going to be getting a slash, and we're going to get an X. So maybe this will end up changing. Right now, I think this is the best way to go. Back to what I was saying. So if we have a string, so we could go now that we've done 1 1 1 1, we could go 2 2 2 2 2 2 or 3 3 3 3 3 3 3. Once we would get to 5 5 5 5 5 though, that's not the right representation. It'd actually be 5 spare, 5 spare, 5 spare. So let's go ahead and try that out. I think that's one of the example games they gave us, isn't it? Yep, 5 spare, 5 spare, 5 spare. And then you would get an extra roll, right? So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. Yeah, so there's an extra. Let's go ahead and just implement that spare game. Let's just call it the spare game. We'll call it all spares. So spare, 5 spare. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And they say that score should be 150. So, yeah, let's run it and see what we get. We're probably going to blow up because we don't know how to handle a spare. Okay, so we got not a number. So let's go ahead and implement a spare. So now it won't break. We won't get not a number, but we only add up the 5s. So now what we need to do is, for each frame where there's a spare, the total needs to be 10 plus the next roll. It doesn't look like, our code's not really set up for that quite yet. So let's see. So with the spare, we don't know what the value we should be making roll value. Should roll value be so in our case, we want roll value to be 5, and that works just fine. For setting the value, it doesn't set for the bonus score. But if it was ///////, we'd still want the total to be 10, and 4 plus 5 only gets us to 9. So we're really doing the wrong thing here. So we could, if it's a slash, we could look at the previous roll value. So let's say it's actually 10 minus line I minus 1, and make sure we convert that to a number. So that should work. If we were to change one of these to a 4, we should still get the same number. Let's go ahead and do that. Well, we'll go ahead and put it back to 5. And then we want the roll bonus to be the next value. So let's go ahead and create something. We'll call it the roll bonus. So basically we add the and let's go ahead and add our roll value. Okay, so we did something wrong there. Or the value they gave us was incorrect. So let's so after the first roll, our score is 5. After the second roll, it would be, we would add another 5 plus 5 for a total of 15. Ah, so our mistake is this last value isn't actually part of our score. It's only part calculated for the bonus. So things are getting really complicated here. When we start getting into strikes, what happens is the next value, we can't use this exact same logic because, so for our roll bonus, we just look at the next line. Well, what if our next line is actually a strike? That actually gets really complicated. We kind of have to start nesting these values. So part of the problem is we really only want to run this logic 20 times. We don't want to run this logic for that last line. So let's just go ahead and max it out at 20. So really what I wonder is should we actually be iterating over frames and not iterating over rolls? That may be the solution. So all our tests pass. Fairly happy with our tests. Our test, we could pull out our line and our turn these into multiple lines for these tests, but to me they're fairly readable. They're good enough. This code over here though is starting to get more and more complex. So what if we did change this to frames? So how would we know? So one of the issues, so this 20 isn't always true. So if we were to do a perfect game, that would only be 10 rolls. Because you wouldn't take the rest of your rolls. So we can either do some refactoring or we can write a test that forces us into something else. Well, let's go ahead and let's go ahead and create a test that's going to force our refactoring. So let's just call it one strike. So what if we had, so that would be 10, and let's say we did poorly in the next time and we hit 1 and then we hit 3. So that's our second frame, third frame, fourth frame, fifth frame, sixth frame, seventh frame, eighth frame, ninth frame, 10th frame. So here our score should be, in our first frame, it'd be 10 plus 1 plus 3, so it'd be 13 plus our next frame, which would take us to 14, take us to 17, right? So that's 10 plus 4, or would it be 18? Sorry, 10 plus 4 plus 4. Okay, so we don't know about strikes here. So we'll go ahead and do that. So we're no longer not a number. Why is that still not a number? So our, okay. So I think what's happening here is we're now going off the end of the array. So I'm going to actually do this. Actually, we will only want to go check 19 rolls. So all ones is off. And our one strike. Okay. So what if we moved this out of here? And Uh, yeah, so we'll still have this. So we want to change this to frames. So let's go set our indexed frame. We're only going to do 10 frames. So we have um, let's see. Times 2. So what we want to do is work our way through the roll, splitting things up into frames, I think. So, just a second, sorry. So we want to deal with the first frame, then deal with the second frame. So once we're done with a frame, we don't care that much anymore. Um, really, um, so let's treat our line more like um, a stack. Um, so let's so we have this idea of a frame. We want to let's say if line 0 So normally we would pop the first two things off. If it's a spare, we'll pop two things off. If it's a strike, we'd only pop the first thing off. So so if that equals x, we would want to let's say frame. Let's see. So let's look at the substring closer. Returns the characters in a string between two indexes into the string. Substring and subster between two indexes. I think that just means it's deprecated, right? Substring. Slice actually might be. I think what we want to pull. Okay. So if we slice, we get the piece we want. Um, but it doesn't change the original string. So it extracts the section of a string we want without modifying the original string. Um, so split splits based on a separator, and then substring returns the parts. So let's go ahead and say we'd slice 1, and then we would say line equals line substring 1. Let's go ahead and pull frame out. So I think all this is going to end up in a loop. Probably just replacing the loop we had before. If line so in all other cases, we're going to pop 2. So whether it's 1, 2, 1 spare, a dash dash, 1 dash, all of those we're going to pull off too. So let's go ahead and get rid of this let. So frame equals line slice 2, line equals line. So are those supposed to be, sorry, not split, we want slice. Okay, so those need to be 0 indexed. Okay, so we want to grab the first thing, grab everything after that. Slice, oh, we want to start at 0 and take 2. Start at 0, take 1. That's our slice, right? Okay. And then we want to do that 10 times. Let's go ahead and put this up first. So I'm just thinking through. Really, we're texting for a strike. We really this number here is basically how far we advanced. So we could do that. Let's say we went through our loop and we looked at our first character. And then we just decided how much to advance. And at the end, we go ahead and advance that. We wouldn't have to actually do the slice. We just substring. And we would loop until our substring so we wouldn't loop until our string line is 0, because then we would still be processing our bonus rolls. So I think let's say we have let's call it advance rolls equals 2. That's our normal condition. If line 0 equals x, then we'll set advance rolls to 1. So then at the end, we can just say line dot substring line equals line dot substring advance rolls. So then if let's go ahead and move this all the way down. Okay, we need that actually in our loop. And we have our roll value. We're now just looking at the first thing. So case 10 or roll value, case X is our roll value plus the next two rolls. So I think a lot of the complication we're seeing here we're really getting to the nitty gritty of the problem is that sometimes we need to look ahead of one roll and sometimes we need to look ahead two rolls. But when we look ahead, we may not be actually seeing a number. We may be seeing something that indicates something indicates what the roll is and have to compute what that is. So we're going to end up. What I'm trying to do is not get into these super dense recursive kind of functions. I think that this is looking very messy and our process is very messy, but I think that's because I'm not building up our tests in the right order. But I also don't see the right order to get where we're going. So this first one is going to be a little bit messy, and maybe our next implementation of this will just be to try to come up with our tests in a better order that drive us towards a solution. So, so our code right now is is a mess. But what I think we are doing is splitting things up into frames now. Our front of our list is always basically we're throwing away roles that we don't care about anymore. And so now we'll go ahead and start dealing with them correctly. So we now have let's work on our default case. We're trying to split up into two frames. Let's go ahead and comment out a bunch of these. And we'll just get it working for the simplest case. This is the idea of refactoring on green. So I probably should have started the refactoring instead of having a test to drive this refactoring. So here we're going to go ahead and so our default case, I don't even know if this is going to be in a be inside a switch anymore. But essentially we want roll 1 to be line 0. And then our total will be roll 1 plus roll 2. Let's see. And we want to convert these to numbers. Let's go ahead and convert these numbers here. Okay, so that works for the case when everything's a number. So in some cases, they're going to be dashes. In that case, we want to do the exact same thing. So let's go ahead and create a function. I'll get roll 1. And function. So if we were to do that and we were to just pass in the line. So let's go ahead and do this. And if we did get roll 2. Then we can go value, let value equal 0 if let's go line so we want char equals line 0. So if char equals that, let's go ahead and just return 0. And we'll go ahead and get rid of this, else we're going to return. Okay. Actually, so what we're trying to do is actually implement this test here. And let's go ahead and do the same thing. Okay. So I think we can do same thing. Here if we do turn get roll 1 line line substring 1. So now we don't need this case anymore. But in the case that, so in the case where it's a spare, our first line will work, but then our second line won't return the right number. Because our logic here is just do the same thing over again. What we want to do, our second line is dependent on the first line, and we've stripped that information out of there. So let's go ahead and put this back. So if it's that, we do that. If it's slash, well, let's go ahead and comment this out real quick. So the one thing we're trying to implement is this here. So we're back to getting not a number there. We want to handle this case. So if we do this, so if it's a spare, we want to actually return 10 minus plus line 0. So now we've got this back to numbers. We have everything right. We just don't have the bonuses, right? So we'd have 5. We'd have 10 5-point bonuses to get us to 150. So it seems like we're actually no longer in a switch case. Let's go ahead and jump out here. We'll go ahead and comment this out. Let some of that stuff be double commented. And so what we need to do is the roll bonus. So, um, so if roll 2 is a spare, then we want to get the roll value of the next one, sorry. And that next one will either be a dash, a number, or an X. So let's go ahead and create a function, another function. So let's go ahead and call it get spare bonus. And we'll go ahead and pass in our line. And so then the character we're going to look at is actually the third one. So because we know we're dealing with a spare, why is that giving us oh, are we inside? Oh, we need to spell function correctly. Okay. So we're either going to return the value or nothing or 10. So let's go ahead and switch on care. X. Return 10. Return plus car. Oh. Okay. So now if equals that, then roll value plus equals get spare bonus. Okay. So that took us a long way to get back to passing tests. So we can go ahead and simplify this a little bit. So now we're green. Let's go ahead and clean up some stuff here. So I think we're still going to need this concept here in the future. Let's go ahead and change I to frame. So we're basically looping through the frames. Each frame we're applying our logic. We can come down here and just change this to let our roll value equals roll 1 there. We don't need that. If we're a spare, then we add the spare bonus. We don't really need roll value yet. We could just be incrementing score. Let's try that. We'll just simplify this down. And score plus equals there. So we've stripped out some ideas here. Okay. And then get roll 1, we get our character. Get roll 2, we get our character. So there's some similarities here. That we could pull out, but I think we have our idea working well enough that we can go on to our next test, the one that kind of started throwing wrenches everywhere. Okay, so that's not a number. So I think okay. Well, let's keep this commented out, actually. So I think in this case, we want to increment score by 10. And then we want to increment the score by this strike bonus. We'll call it get strike bonus. And then we want to advance rolls only once. And then we don't want to do any of the other logic. Oh. Okay. So we care about carry equals line 1 because we only do this on a strike. So we're only looking at the next character. Let's go ahead and return a 0 here. So this should get us, again, need to spell a function correctly. So here we are just adding up the points. We're not getting our bonus for our strike. So let's go ahead and create a variable called bonus because we're gonna have to do the same logic twice, I think. So let's go let bonus 0. We're gonna go ahead and return bonus. Excuse me. Let's go and call this roll 1. Let's call it bonus roll 1. And let's go ahead and copy that for bonus roll 2. Bonus roll 1 is that. Then bonus. Then we don't do anything. If it's x, then bonus plus equals 10. Okay, so that we don't actually have this case. So let's go ahead and do this the simplest way possible. So if we have bonus roll 1 and bonus roll 2, then our strike bonus is just bonus roll 1 plus bonus roll 2. Okay. So that doesn't handle the case where our strike is followed by a spare. So let's go ahead and implement that. So if we did start with an X, then we did 3, then we did spare, then we did 5. So that's frame 1, frame 2, frame 3, 4, 5, 6, 7, 8, 9, 10. So we should get 10 for the strike, 10 for knocking down all the pins for the strike, plus another 10 points. So that's 20 for the first frame. So after the first frame, it would be 20, right? Because we get 10 plus 3 plus 7 for 20. Then our next frame, it would be plus 15, so that'd be 35. So our total should be 40. If my math is right. If it's not, we'll discover pretty quickly. So 10 plus 3. Okay. So that's why we write programs to do this, because we don't want to have to do this in our head. Okay. So now our get strike bonus is blowing up. And so we don't have to worry about line 1. It's really if the second one. So we'll go ahead and let bonus equal 0. If, well, we'll put this lower. If bonus roll 2, then our bonus roll would be 10. So again, we still don't need this yet. Okay, so this doesn't handle the case where either of the two strikes where the strike is followed by gutter balls. So if we start off with a strike, so that's 2 frames, 3 frames, 4 frames, 5 frames, 6 frames, 7 frames, 8 frames, 9 frames, 10 frames. So that's easy, that's just 10. So now we'll go ahead and say plus equals bonus roll 1. If bonus roll 2. Okay, so we are failing. An earlier test. So what did we break? Oh, so our logic is just way off. If it's not, this is what I wanted to do. I inverted in my head, and there we go. So if either of them are blank, they just don't get added in. So we don't handle the case of strike followed by another strike yet. Okay, let's go ahead and write that test. So we have the let's go strike followed. So real quick, let's think this through. So we have the case where x1, and then we have xxx. Let's go ahead and do strikes followed by strikes. I was trying to think, is there a difference between a test that tests for 2 strikes following a strike and a test for only 1? And there probably is, but we're going to go ahead and do the more complicated. So let's say you did so this would get you the next 2 rolls, which are both 10s. This would get you the next 2 rolls, which is a 10 and a 1. This would get you the next rolls, which is a 1 and a 4. So we have, first one would be 30 because you get 10 plus 10 plus 10. The next round we would add, you would get 10 plus 10 plus 1. So you'd add 21 for 51, and then 51, and then the next one you would add 10 plus 1 plus 4, so you'd add 15. For 66. So we think the answer is 66. But our test is going to fail and give us nan. Okay. So if it's a dash, we give nothing. If it's a 1, we give something. And we want to do the same thing for bonus roll 2. Realizing that that's going to need to be refactored. Oh, we forgot the rest of our... Okay, so we start with frame 1, frame 2, frame 3, frame 4, frame 5, 6, 7, 8, 9, 10. Okay, strike followed by strikes. So we're doing this first part. What we actually want is else and do the same thing here. So we're going to add 10. $71. So let's see if it was our math or our function is wrong. Okay, so the first round you have 0. So when you start the game you have 0. First frame you're going to add 10 plus 10 plus 10 for a total of 30 to make your total 30. The next frame you're going to add 10 for your roll, and then your first bonus will be 10, and then your next roll will be plus 1. So that's going to be 21. So 51. And then your next roll is going to be... So I haven't quite got there yet, but I'm pretty sure I know what I did wrong. I think we added all the bonuses, but then forgot the next 2 rolls. We just didn't add the final frame. So then you get 10 plus 1 plus 4. So 15. So that takes us to 66. Right, and so then what we forgot to do is we just need to add the next frame, which is 1 plus 4, which is 5, to take us to 71. So our number here was wrong. Oh, and this is not valid JavaScript. Okay. So our tests pass, and we wrote some code here that is just absolutely horrible. So we short circuit out sometimes. Not sure we need to. And I'm pretty sure we can. And we're doing the exact same thing over and over again. So let's say okay, I like that. Well, let's go ahead and just do what are we taking in? We're only taking in one character, right? One roll. So if we so if the roll, let's equal to X, let's try return 10. Now we can go ahead and do this. If roll does not equal that, then we return roll. Or we return 0. Then can we just do bonus plus equals bonus roll value of bonus roll 2. And we should be able to comment this out as well. Oop. And let's go. One. Okay. So now our function is we set bonus to 0. We get bonus roll 1, get bonus roll 2. If bonus roll 2 is a spare, then we return 10. Otherwise, we have to add up the values. And we do that if it's a strike, each one is worth 10. Otherwise, returned it's okay. So that could be a switch statement. So you do switch roll, case X, return 10, case. Yeah, let's go ahead and switch that out to a first switch. Just see if that is a little bit more clear. 10 case return 0. Okay, I think that's a little bit more understandable. Let's make sure that does the exact same thing. And if we wanted to, we could add the spare case here, which shouldn't ever happen. If it did, then we could throw an error or something like that. But our code doesn't necessitate that yet. And we made bonus roll value a child of get strike bonus, just because we didn't think that made sense anywhere else. It only makes sense within get strike. You can't get bonus roll value somewhere else, I don't think. Well, get spare bonus. That's the exact same logic there. And roll. So it's not the same there, but we could use it within get spare bonus as well. So let's go ahead and pull this out. And let's make sure that works. Okay, and let's go ahead and call this bonus roll. Okay. So we have get roll 1, get roll 2, get spare bonus, get strike bonus, get bonus value. We have rules for getting X. Okay. This handles our spare cases. Okay. So what other test cases don't we handle? Let's look at some of the examples and see if that sparks any. Okay. So this did 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's go ahead and make sure we write that. Make sure that that one works. Different values, no spares. So we expect 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. be, and it says the answer is 60. And we'll go up here and correct this. Okay. Let's go ahead and check out the perfect game. Expect. So that would be 10 strikes plus 2 bonuses to be 300. Okay, so it works for that. The heartbreak game, let's go ahead and try that. So that's 9, 0, 9, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you don't get any bonuses for that, and so it says that is 90. Okay, we've already done the spare. So I think that fully implements our rules. So our expectation is that any value we pass in, any valid bowling game, we will split out the right score. I can't think of any cases where this wouldn't. Maybe some will jump out in the future. So our tests are pretty good. I think we might have been able to drive our tests a little bit better, because things were very smooth, and then things got really ugly here. We had a lot of problems. Actually, it was here where we first started getting our problems, I think. And so our codes, we go through 10 frames. Advanced rolls, we probably could put so we could either default to 1 and change it in the default value, or either way we need to do something like that. This idea of shrinking down the line, it worked. Maybe there was a better way to do this. Maybe there was have an index that we would advance about where we're starting from. Here we're hard coding indexes, but it's always this one or the next one. So we could have pulled those out into their own functions, maybe. Get roll 1, get roll 2. So get roll 1 and get roll 2, I mean, they are different because the first one can't be a spare, but there is some logic there that could be reused. Get spare bonus. We just get the bonus roll. Get strike bonus. So we use a bonus roll there. So if we didn't do this, our bonus value function would have to calculate that, and it would need a lot more information. It would make this a lot harder to calculate if we put a slash in there. So we have to special case that. Yeah, so that's looking fairly good. Let's go ahead and switch over to our what the book says to look out for. So discussion points. Did you do any design before you started coding? No, we just jumped right into it. Maybe that's something we should have thought about in advance. We could have thought about frames and roles and bonuses and stuff like that, and maybe we could have come up with a pattern ahead of time that we could have been driving towards. If so, does your code have this design now? That's irrelevant. At what point did you realize that you can't simply loop over frames, that you in fact need to refer to previous frame as well as the current, so I should say previous frame, as well as the current one in order to calculate the score? In an ideal world, when should you have realized that? Did we ever actually need the previous frame? We didn't really need the previous frame. We did need the subsequent frames. Um, so really things got hairy. Really things got hairy when we got to the um, strike, and when we started to look ahead for bonuses, and when those bonuses could be something that needed to be converted, um, and that's really where things got hairy. And then strikes, meaning that we didn't know how big a frame was going to be, how many characters a frame took up, without figuring that out. So that's really where that came in. When should we have known that? Um, well, maybe at the beginning. If we had planned out ahead, we might have known that. We would have looked and seen that each of the test cases are actually different lengths, and that the bonuses have to look ahead, and we may not know what those are. So that's something that should have been obvious from the beginning. Look at the code you ended up with and compare it to the description of the rules of bowling. Is there any similarity in the words used in each? Um, so we have line and frames, um, spare and strike. Um, so use the word pins. I don't think the word pins shows up in our code anywhere. Um, and there's a couple places where we're using the word car, when that probably should be something else. I think there's also a confusion, sorry, in some places. Are we dealing with the raw character, or are we dealing with the actual um, number? So here we call it value once we've converted it. Here we just call it car before we've done anything. Um, so so here maybe these functions should be better. Things should be better named here. So instead of car, maybe that should be roll, and then maybe the bonus roll. Um, oh, this isn't bonus roll. This is the previous frame. So maybe that's what it meant. Not you had to look at the previous, not frame, but value, character. Maybe I transcribed that text wrong. So yeah, maybe we should pull that down to a function called, or a value called previous role, current role, previous role. Um, let's go ahead and make that change now. Let's call this, actually, sorry. Okay. So there is a replace value. Um, in VS Code. Um, on Windows, that's F2. Um, that doesn't seem to be the same thing. Oh, yeah, it is on Mac as well. For some reason, I don't know what I was thinking. So let's go ahead and equals line 0. Okay. Let's just call this role. Okay. How did you decide which tests? Oh, did you do enough refactoring? Um, so our tests are basically all the same. I don't think there's any more refactoring we could have done there. I think there might be some more refactoring we could do here. Um, I'm not sure it's obvious what's happening here. Um, so if we maybe pulled out a function, say, um, is a strike. Um, so like strikes are handled explicitly. Our nominal cases, fine, but then our spares kind of get handled mixed in. So I wondered if those were more explicit. So you handle your strike case, your spare case, your nominal case. Um, Maybe this code here would be more obvious. Um, and of course, we could always pull this out into a handle frame function or something like that. Um, and then maybe if we did all this, right now all of our functions are just, oh, we have our functions inside bowling. Um, yeah, so those haven't linked out. So maybe there's some um, more refactoring we could do. But the more interesting question is, um, did you know for refactoring? How would you know? And I think this kind of comes down to you kind of have to look, you have to write your code and then refactor your code, and then you have to kind of try to look at it with fresh eyes. And that's the hardest part. Um, what would I be thinking if I were somebody else? Or what would I be thinking if I hadn't been the one that wrote this? It's a little bit of um, empathy for an imaginary person that would be coming in. What is in their head? How would they be thinking? What pieces of information have you given them, and what pieces of information haven't you given them? What pieces of information are only in your head, and trying to figure that out. Um, that's very, very hard to do, um, but it is the difference between good and bad code. Is when you can do that, put yourself in the mindset of somebody else who would be reading your code for the first time. That's how you can write good code, or that's how you can know whether your code needs more refactoring or not. One of the things I see a lot of times is people will get code to work, and then they'll declare it done. And when you a lot of times I'll jump into people's code and it looks like their code is a rough draft. Um, so we want to refactor so that as we're figuring things out, we can write whatever we want, as long as it passes our tests and does the thing we need to do. Then we want to kind of shape those into things that are um, more self-describing, more um, easier to understand, things that we can look at and just understand a little bit better. So, um, if we jumped into a function like this is a pretty big function. Um, and of course, we return our score all the way down here. That's a bad thing. So they have to. We've actually broken up the flow. So we set our score, we loop through, and return our score. Um, yeah, so that's takes a lot of balance, and it takes a lot of trial and error, and just thinking, trying to put yourself in somebody else's shoes. Um, how did you decide which tests to write and in which order? Did it matter what order you implemented them in? So I very much think it does matter which order we implement them in. Um, I think um, because there are tests that require you to figure out the bonus situation, and then there are tests that require you to figure out the frame splitting idea, or frame calculating idea. Um, and the order you put them in may affect how things come out. Now, once you have things working, ideally you'd be able to refactor into something that's obvious and is more explicitly about the problem. Um, but I do think the um, order matters. Um, as far as the order I did them in is, I think you should, for this kind of problem, always start off with a gutter ball game. What is null? What is the zero case? Which lets us just write return zero. Um, then we kind of want to get to a nominal case, as quickly as possible, where we're no longer returning something hard coded, but we're looping through things. And then I just kind of built it up for there. The next most common thing is complication is the spare, all spares. Now, we could have done one spare. Um, I think we went with all spares because of these examples here. I think I was kind of thinking of these examples and went with those instead of coming up with my own. Um, as we see, I went with 11111 just because that's simpler. So I was able to break that habit here. But still, I filled out the whole thing. Um, I don't know if taking things in smaller pieces or not would have helped or not. So that's something we can think about next time is what order would we want to do these things in? How do we want to break things up? Um, or is there some other thing we want to work on with this? So I don't know that we'll do this one again. Probably. I don't know if we'll do this again next. But if we do, join me for that. This video was a lot longer than I expected it to be. But it's been a long time since I've implemented this. I'm basically re-implementing it from scratch, um, and it gets kind of complicated as we saw. I think we were able to simplify it some, though I think we could definitely simplify it more. So maybe we'll tackle this one again soon. So join me for that. Thanks.